Hello everyone. Now we are on our lecture note 1 of 3, which is involving indices and logarithm. But for this video, we just are going to focusing on indices only. Okay. So rules of indices actually make solving complex problems involving power a lot much easier. So basically, there are 4 rules of indices that we need to know, which is for multiplying, dividing, and raising power to a power, and also negative index. So we just need to focusing on this one. Okay, multiplying, dividing, raise a power to a power, and negative index. Okay, for multiply. When we multiply indices, we just need to add the power together. When we multiply, this one is multiply, right? So when we multiply, we add the power together. And when we divide, this is divide, right? Operation here is divide. We need to minus the power. If the base is dividing, so the power need to be subtract. Okay, and for a power is raised to a power, meaning we have power here, 2 to the power of x is raised to the power of 2, then the index must be multiplying with each other. Okay, we need to multiply the index together. Alright, so we have 2 different examples here. Either 2 to the power of x is raised to the power of 2, or 2x is raised to the power of 2. It's different, okay? So for this, we need to multiply everything inside here by to the power of 2. Okay, it become like this. And then solve 2 to the power of 2 is equal to 4. So the answer will become 4x squared. Okay. So here is different, okay? Now, what about zero index? Is very simple, meaning anything to the power of 0 will become 1. So why it become 1? I need you to explore it by yourself and explain to your friends. Make sure they can understand. Now we go to negative index. A negative index means the base, the base must be moved to the denominators. Why? Because when there is a sign changes, if there is a sign changes here, then we need to cross the line here, negative m, right? So normally a to the power of m. So if negative m involve change of sign, we need to cross the line. It will become 1 to the power of a to the power of 1 over a to the power of m. When there is negative index, we move the base to the denominator. The base is a. So a here will be moved to the denominator, a to the power of m. Move to the denominator. Okay. Now let's go to example 4. So I hope that you can clearly see or clearly remember all the rules of indices involving that's very important, okay? Now let's go to example 4, because example 3 you need to solve it by yourself. We go to example 4. Okay, so first and foremost, for the first example, A, simplify each of the following expressions, meaning we need to simplify the question until it's very simple, meaning we cannot simplify it anymore. So here we have 3 to the power of 5 multiplied by 3 to the power of 6 over 3 to the power of 4. So first and foremost, is the question have the same base? Yes, the same base here, because involving 3, everything is 3. And then for this one, we solve the numerator first. Okay, the numerator first. So we have 3 to the power of 5 multiplied by 3 to the power of 6. If multiply, we need to add the power, right? So we have 3 to the power of 5 plus 6 over 3 to the power of 4. Okay, so we just plus the index here because multiply. The base is multiply with each other. Now involving divide. So if the base dividing, meaning the index dividing with each other, we need to subtract the power. So it will become 3 to the power of 5 plus 6 minus 4. So what's the answer, class? It will become 3 to the power of 7. Okay, that's the answer. Okay, it's a very simple example. Now we go to example B. For example B, okay, to make the... So first and foremost, we must make sure is the number that the question give is in the simplest base. No, right? Because we know for 49, if we multiply 7, multiply by 7, we'll get 49. Okay, so meaning the lowest index for 49, the lowest base for 49 is 7. So here we solve first. It will become, sorry. So it will become 7 square x square y to the power of negative 4 raised to the power of half. Okay, 7 square x square y to the power of negative 4. Now it is in the lowest base, which is 7. So what can we do next? Okay, there is different different integer involving here, different things. There are 3 elements here in this bracket itself. We have number 7, we have x and y. So what can we do? We separate all the things there, meaning we try to solve one by one. 7 square, okay, to the power of half. And then we have x square to the power of half. And y to the power of negative 4 is raised to the power of half. Okay, solve one by one. So now 7 square become, okay, so this one becomes 7. Why? Because here, okay, becomes 7 here. And then become 1. And this one, negative 4 dividing by 2, you will get negative 2 here, okay? So it will become 7x y to the power of negative 2. But that's not the final answer yet. Try to, if there is negative sign, okay, make it in the form of fraction. So for the final answer, we have 7x over y square. So that's the final answer. Can you follow? I hope you can. If you cannot follow, then please rewind this video over and over again until you can understand. Okay? Thank you. Now I hope that's enough for B. Now we go to question C. So when you see the question, please make sure that it is in the very simplest base. So now it's not in the simplest base, right? For C, we have 4, 8, and 16. What's the base? The simplest base for all three? Yes, 2. 4, we have 2 to the power of. Okay, now we go straight away to the base. The simplest base is 2 to the power of 2 to the power of n divided by. For 8, we have 2 to the power of 3. Yes, to the power of 3 become 8. If you're not sure, please use your calculator. For 16, we have 2 to the power of 4. Okay. And then, for this one, power raised to a power, we just multiply the power. It will become 2n divided by, for this one, it become 2 to the power of 2n multiplied by 2 to the power of n. So now, if divide, we minus the power. If multiply, we plus the power, right? And if the operation here involving divide and multiplying only, we just need to solve from left to right. Okay, so divide, we minus the power, become 2n minus 2n plus n. So what's the answer? Yeah, the answer is 2 to the power of n only. So that's the simplest form. We cannot simplify it anymore. Okay. Now we go to the last question, which is question D. So for this question, this is a bit trickier, but try to follow as much as you can. So for this question, how to solve this? What can we see here? We know that there is 2 to the power of 2, and here also we have kind of same thing, 2 to the power of n. So okay, we have 2 to the power of 2 and here, okay, 2 to the power of 2 and 2 to the power of 2n as well here. So the idea is we need to simplify it in the power of 2 to the power of 2n. Okay, try to simplify first. Okay, how? We have I'm sorry about that. Okay, so we have here 2 to the power of 2n. Okay, dot here means multiply by 2 to the power of 4. That's why it will become to the power of 2n plus 4, because multiply you need to plus the index. Okay, so here 24 dot, okay, 2 to the power of 2n, 2 to the power of 2n minus 2 to the power of 2, right? Okay, dividing by 10, 2 to the power of 2n. Okay, so okay, we cannot, okay, what can we solve? We can solve this here. This one is actually, okay, multiply. Okay, what can we see? We know that each term have 2 to the power of 2n. So we can actually remove this. Okay, because each term have 2 to the power of 2n. So what is left if we subtract this? I mean, we omit these 3 terms here. I mean, all the same thing. So we omit this. What do we have left? We have 2 to the power of 4. 2 to the power of 4 minus 24. Negative here. 24. Okay, 2 to the power of negative 4 meaning it will become 1 over 4, right? 1 over 4. Okay, dividing by 10. So this one become 4, this one become 6. So to the power of 8, to the power of 4 is 16, minus 6 divided by 10. So we have 10 dividing 10 will become 1. So this is the trickiest part, but I'm sure you have no problem with it. Okay, thank you, class.